Hello everyone. In today's video, I'm going to be going through an attempt at solving one of the past AMC10 contests. In a previous video, I did something like this, but I didn't time myself. I just treated every single question as a separate problem and tried to work through more or less as far as I could. And at the end of that, I discussed a little bit about what kind of strategy I would use if I were writing the contest for real. So I am going to do that this time. I'm going to set a timer for 75 minutes, which is the time limit for the AMC10. And the strategy I'm going to use here generally is I'm going to go through the problems essentially one at a time. If I know how to solve one instantly, then I'll try and come up with a solution. If I think I have a really good idea of something that'll work, then I'll attempt at doing that. But if I'm very clueless, then I'm just going to skip the problem outright because there's no way I'm going to be able to solve all 25 questions in 75 minutes. The way that I decide this, a lot of it is going to be, based on what kind of areas of math seem to be involved with the problem. If you looked at my previous video where I took as much time as I wanted, I had a lot of trouble with problems that were more advanced in geometry and combinatorics. So those are the kinds of ones that I'll probably skip over quickly, and I'll search for ones that are a little bit more towards my strengths. At the end of the test, I'll probably come back and review some of my solutions and give some commentary on what was going on in my mind as I went through each problem. I'm not going to give commentary live while I'm solving the problems. So it's going to be, some future version of me giving some commentary on what I thought as I was working through. And then I'll even tally up what my score would be, go through the problems and figure out which ones I got correct and incorrect, and then report back at the end and discuss my experience. Okay, so I've got my timer here set for 75 minutes. Let's get started. Question 1 was basically just a sequence of arithmetical operations, so there's not too much to say here. I got this one correct. Question 2, some fairly straightforward geometry. Not much to say about this one either, just working out through the whole problem and knowing the formula for the area of shapes like this. I ended up getting this one correct. Question 3 was surprisingly frustrating. So I don't know if I had some kind of mental block or something like that. My first attempt was to try and count the number of 3-digit positive integers that will satisfy the property here. I just struggled a lot to try and figure this one out. I ended up skipping it at first, and later on I came back to try and answer it. When I came back, I figured out, I had a little insight, which is probably one of the intended ways to solve this problem. And even with that insight, I ended up getting the question incorrect. So this was, I suppose, a little bit of a surprise to get such an early question, not only struggle with it and take so much time to get an answer, but to end up getting it incorrect. Really don't know what was going through my head at the time that made this one such a struggle. Problem 4 also took a little bit longer than I expected. I think, if I remember correctly, I think I may have made a small arithmetic mistake somewhere, which was completely throwing off the numbers, and the answer I had was nowhere close to any of the answers provided. But when I went back and checked my work, I caught the mistake, and then it kind of just came very easily. So not really a difficult problem, but if you make mistakes partway through, that's going to come back and hit you. Problem 5 was fairly straightforward. I think I just straight up computed this thing by hand. I don't think I used any sophisticated techniques. There might be some nicer, quicker ways of simplifying this expression. But I just went and kind of brute forced it, and the answer I ended up with was one of the options, so that's what I went with, and I got it correct. Problem 6 is another one that I kind of struggled with a little bit. I didn't know, I think I just didn't know exactly what approach to take, which is kind of surprising because a lot of other problems that I've worked on my channel would have gotten the solution. Like they're similar enough to this one that if I just taken that approach, I would have figured out the solution, I think. If you just write out what each of these numbers is in terms of a sum of powers of 10, then factoring that number is pretty easy. So I believe I left my answer blank. I did not make a submission on this one. But I think if maybe I had a more clear mind or took a better approach earlier, I think this one would have been really quick. But I left it blank. Problem 7, all in all, pretty straightforward. I think I did a little bit more brute force on this one than was actually necessary. It just came down to actually counting all of the possible formulas. If you know how in a quadratic polynomial the roots kind of add and multiply together to give you the coefficients in the polynomial, then you can just sort of start listing off all the possible roots that work. Given that there's a number 36 here, you know what the factors of 36 are. Yeah, so I basically just ended up, I more or less just listed all of the possible roots, and then computed the corresponding values of k that worked and counted them all up and got this one correct. Question 8, I think took a little bit longer than I would have liked. It's not really a combinatorial problem, but it is sort of a counting problem in some sense. I obviously was not going to brute force this one completely, but I started with a brute force approach so I could see the pattern that was going on, and that way figure out exactly how many things I was supposed to count. I was a little bit nervous that I might have had like a rounding error or off by one thing, because just if you go through the question, you're on your own and see what the pattern is. You sort of have to count things in certain sets of 7, and but obviously the number of sets we have here is not divisible by 7, so you have to round up or round down. And anyway, I got this one correct. Took a little bit longer than I would have liked. So problem number 9, I kind of cheated a little bit. So at first I attempted to try and simplify this and write it in the form that they're given so that I could figure out what the values of A and B are. But then what I did instead is I just took the original expression and I truncated it after a very small number of terms and computed that by hand and figured out what the answer is. And then I might have done it again for a slightly larger total number of terms. And then I just saw the pattern and I assumed that the pattern was going to continue for no matter how large the sum is. So I ended up getting the correct answer here, but I didn't really do it in a direct way. I kind of just solved on a very simplified version of the problem and assumed whatever pattern held there was going to continue forever. Yeah, not really a true mathematician's way of doing something like this, but it's contest math. It's a little bit different. Problem 10, I don't know if my approach was the most direct or sophisticated. This was kind of a brute force way of doing it as well. I just started listing off a whole bunch of combinations of numbers that I would try to satisfy all the conditions given as tightly as possible, basically. And I just sort of stopped when I found the first collection of numbers that worked. So it was somewhat brute force-ish, there might be a more elegant way of doing this, but that was the first thing that came to mind, and I just went with it. So problem 11 was a direct logic problem. It's really just about understanding how, existence and the existence quantifier and the universal quantifier and implications and all that kind of stuff with negations work. So I just worked out what exactly the correct statement is. Yeah, I don't know if there's much to say about this. I think at one point, to try and convince myself I was correct, I drew a little diagram to try and, more intuitively understand what the correct answer was going to be. But I got this one correct. Problem 12, fairly straightforward probability question, actually. Really just about understanding probabilities of a fair die and doing repeated independent events and how those probabilities work. I thought this one was quite easy, actually, considering the level, or considering how far into the test we are. I thought this question was pretty simple for where it's located. Didn't take me very long and ended up with the correct answer. Problem 13 is another one that I did not spend too much time thinking about and ended up skipping pretty quickly. I think this very large number, more than 31,000, and the fact that we're dealing with cubes kind of scared me off. I wrote down a couple of lines of things, basically a restatement of the problem, but ended up skipping this one pretty quickly. Problem 14, I spent quite a bit of time on thinking about. I sort of started to brute force things and try and construct a set with the properties that are given. And I did come up with an answer, but I was not very confident and I didn't end up submitting the answer. So I'm going to say that this one went unanswered, even though my the answer that I indicated was correct. I wasn't confident enough to actually submit it. Problem 15 was fairly straightforward, I thought. If you know the formula for an arithmetic sequence, then you can pretty much explicitly write out what all of these terms are equal to and get the answer pretty quickly. So nothing too interesting really happened with question number 15. So all of the remaining problems from 16 right to the end, I didn't actually ever submit an answer. And in fact, I didn't even, if I remember correctly, I didn't even really come very close to answers with maybe one or two exceptions. So I'll just sort of quickly outline my thoughts on some of these. Question 16 was a geometry thing where I did not immediately see the approach. And so like I said in my strategy, I was going to skip a question like that. Question 17, this one I should have been able to get easily, but I just didn't. I didn't see an approach to take right away and decided to skip this after thinking about it for only a few seconds. Problem 18 seemed very interesting, and I thought this is the first problem where the difficulty had really jumped up. I played around with this one for a couple of minutes and then wasn't really making any progress and decided to just move on. Problem 19, I did not think about for very long at all. It looks like a Conway's Game of Life type thing. And I didn't see any kind of quick approach, so I more or less skipped this one. Problem 20, again, a geometry problem, not my strength at all. I didn't think about this for more than a few seconds and decided to skip it. Problem 21, I did spend a little bit of time thinking about. I wrote out some things that I thought might have helped approach a solution, but didn't really see where I was going with it, I guess. and didn't want to spend more time. At this point, I'm kind of thinking, let me try and find at least one more problem that I'll be able to take to the finish before the time runs out. Problem 22 is one that overall, in terms of the necessary knowledge to figure it out, is actually really not difficult. And I started to draw some diagrams and write some things down, but then decided that even though it wouldn't be difficult, it would be very long and tedious to figure out, and that my time would probably be better spent on something else. Problem 23 sounded very interesting, and maybe the kind of thing that I would have liked to work on for a longer amount of time. A probability problem like this, if you can figure out some interesting method or theorem that applies, sometimes the answer can just fall right out. I just didn't really see exactly how to approach this one, so I skipped it. Problem 24 is one that I think I was really on track to eventually answer. I had eliminated one or two of the options pretty quickly, and was really just struggling to try and create a function which achieves the maximum value of this difference. And this is the timer expired just as I was sort of maybe a few minutes away from being able to figure this one out. So, when I read this problem, I thought that it was one that was going to appeal to my strengths a little bit more. And so I decided to kind of really go for it. And because my time expired partway through problem 24, I didn't even read problem 25. All right, my time just expired, I think, just as I was about to finally figure out question or problem 24, which is fairly straightforward inequality defining this family of functions. I ended up skipping quite a few questions. I guess I knew I was going to, right? With only 75 minutes, this was sort of part of my strategy. But I think maybe the skipping began a little bit earlier than I expected. Anyway, I'm not going to go too long here. I will give a commentary on what I remember that I was thinking through each of these problems, and I'll do that, over top of the video. And then at some point, I'll go back and tally up what my score was going to be. Thanks for watching. So there you have it. That's, my performance, my legitimate attempt at the AMC10. I haven't been keeping tally here of how many questions I got correct or incorrect, but I'll pop that up on the screen right here so you can see. It was kind of fun. It's nice that, the official test is quite short, only 75 minutes, so you can sit down and work through a practice test like this pretty quickly. A few careless mistakes early on, but I think my strategy was pretty good in terms of just skipping problems quickly if you can't figure them out. In fact, I probably should have done that a little bit more when we got to the midpoint or so in the test.